Hey, it worked. The internet worked if I stared at it long enough. Yay. Oh my gosh, what a morning. Oh, it's just been one of those things. Y'all hear about Pinelands? I'm not in the Pinelands Union. I'm in the Barnegat Union. But I was forwarded a letter that that was a response to the union, basically going to the Pinelands superintendent, basically being like, listen, this is what we need. And the Pinelands superintendent's like, okay, fine. Pinelands, we're going virtual for the next week. And then we'll reevaluate at the end of the week and we'll decide whether or not we continue going virtual or we go back to regular instruction. And everyone in Barnegat's like, what the heck? That's where we're at. I don't know. It's been quite a Christmas break. Me and my wife bought my kids a trampoline. It is the best decision we ever made. Yes. I have almost hurt myself on a number of occasions. It's been fantastic. Yes. It's a 12-foot, right? Put in the backyard. I had to clear some trees for it. It's no big deal. But, yeah, this guy has a friend that goes to Pinelands. And she was told by a friend. My son is 45 pounds, and my daughter is like barely 25 pounds. So when we play popcorn, they're like all the way up here. It's the funniest thing ever. I'm afraid they're going to get hurt. But yeah, trampolines are awesome. They are. Okay. Anyway, that's the big present that we got from. Oh, goodness. So here we are. We have how many class periods? 1, 2, 3, 4, 5, 6, 7. You have 7 class periods until your final exam. 7 class periods. My goal for this week is to wrap up some of the things that we were doing right before break with the binomial probability distribution. I wanted to wrap up some stuff with that, and then hopefully knock out an assessment for that. And then I wanted to finish up with the very last thing that I wanted to talk about in this course, which was linear regression. And we'll wrap that up. And then we will get to a final exam review. And then we will knock out the final exam. Yes, 7. I know. Oh, goodness. So you guys know how the next few weeks is going to work. You guys do know you have no federal holiday. Martin Luther King Day. But that's why we only have 7 class periods, because you have today, Wednesday, Friday. You have Tuesday, Thursday of the following week. And then you have no school on that Monday. So you have Tuesday, Thursday of that week thereafter as well. And then the week of the 25th is, well, midterms, but for this class would be our final exam. Well, I don't know which day of the week it would be. I believe it's the 29th, but I do have a calendar. Marking period officially ends on the 28th, actually. So Friday the 29th would be the beginning of the 3rd marking period. Yeah. Yes, according to the paperwork that I have, yes. So I don't know if it's an A-day or a B-day. Depending on what it is, obviously, you'd go to whatever 3rd marking period class, yeah. But we'll figure that out when the time comes. Anyway. As I've told people in the class, I wanted to make sure they had their Chromebooks open because I wanted them to have of course, first time, say it with me. No, you're not gonna. I'm gonna need those notebooks out and open. So, like I said, the calculator on the Chromebook is going to be needed to get this stuff done. Because I don't know that many people who are going to be doing these calculations by hand. I wanted to refresh and review with you what is going on with this stuff and where we're going to go with it. So, Chapow, today is the 4th. For some reason, it does not feel that weird to write the 21 at the end. It doesn't really feel that weird. Right? I know it shouldn't, but it does. It's kind of nice. Yes. Anyway. I wanted to just refresh and review binomials. So again, we're all on the same page with this, and I'm going to be taking this a little bit farther than what I did before we left for break. Which, before we left for break, I only had you on that Tuesday, right? During that 3-day week? Wow. What a world to live in. Okay, fine. First of all, in a binomial, let's call it a PDF for the sake of argument for now, there are three main variables that you have to type in. Now, obviously, the interface that you have on the calculator is slightly different. No big deal. Sorry, I'm just reading the comments on the chat. But the variables have a different interface on the calculator that you have. But typically, it comes down to these three variables. N being the number of trials. P being the probability of success. Make sure we're very clear on that. And I'll go back to the interface that you have on your Chromebooks, just so we can see those three pieces, and we'll put them all together for the example that I want to do. But N is the number of trials that are supposed to be performed. P is the probability of getting a success on that trial. And X is the number of successes that you are looking at. So if I flip over to my calculator and I hit, and again, you would do this as well to find out where this thing is, second vars, V-A-R-S, second vars, and you go down to option A, which is Binom PDF. They don't spell out the full binomial, and hit enter on that, then yes, they do give you these three variables that you are to type in. Trials, meaning the N value, P being the probability of success, and the X value being the number of successes that you are looking to get. For the example that I would like to do, I would like to go back to a dice example. Now, a dice, or a die, I should say, basic thing, 6 sides. If it's rolled, it has an equal chance of landing on any side. Are any of you guys familiar with the game Settlers of Catan? No? Weirdos? No, it's a board game. Anyway, no, Settlers of Catan is a board game where you roll dice, and depending on the results of the dice, you collect resources, and with these resources, you can then build certain things in order to progress in the game, in order to gain victory points, blah, 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 blah. Anyway, Settlers of Catan is a pretty advanced game. They recommend that it's only ages 10 and up. My son is 6. He beat me and my wife yesterday. We've been playing that game for like 8 or 9 years. And my son came in and beat us yesterday. You've got to be kidding me. Anyway, back to this. You have an equal chance of any result showing up on the die. She says she has it's a cousin to Dungeons and Dragons. It's not really role playing. You're not really pretending to be a character. You're just trying to destroy your enemies. I don't know. It's a fun game. But anyway, I'm looking at the result of getting a 4. So with the binomial, I'm going to roll this thing a certain number of times. I don't know. Pick a number that's not 4, that's somewhat manageable. 2? No, I'm gonna overrule you. No, that's definitely, we're not doing 21. We can do 5. I think 5 would be more manageable. No, here's the thing. What I'm looking for, and I didn't tell you this, I was looking for the number of trials. Number of trials. We do 21, we're going to be filling pages and pages of work. Oh, okay. Oh, right, because I forgot. So I'm going to say we are going to roll the die 5 times. A success is rolling a 4. We're going to roll the die 5 times, and no more than 5 times. To be manageable, I wanted to do like a limited number of times. 2 is like way too little. 6 or anything more than that would be way too much. I was just trying to see what it felt like in my head. But this is what we're going to try and do here. Now, in terms of the binom, or the binomial, I should say, It is either a success or a failure. That's what it comes down to for a binomial. It usually is a success trials. So hold on. N is equal to 5. What is P equal to? One out of 6. Now that would be a decimal, obviously, but I'm going to leave it as the fraction for the time being. There's a 1 out of 6 chance of getting a success. It's not saying that 4 is better than any other number, but it is saying that that is what we are looking to happen. We're looking for that 4 to actually occur. So there is clearly a 5 out of 6 chance of getting a failure, but that's not what we're looking for. We're looking at the chances of success. Now, how many? Well, that wasn't really specified. How many 4s would have to be rolled? I don't know. But think about the possible outcomes. Out of 5 rolls of the die, you could get none of them being successful. You could get 1 of them being successful, 2 of them, 3 of them, 4 of them, or all 5 of them being successful. You guys ever play Yahtzee? Yahtzee. A Yahtzee is 5 of a kind. Just saying, Yahtzee's fun. Lots of math in Yahtzee. You know, Yahtzee is a made-up word. Yeah, it is. It was made up for the game. Anyway, back to this. I'm full of it today. So how many successes are we going to get? Successes, question mark. Well, we could have 0 successes. And if we have 0 successes, then we would have to calculate a binom PDF of 5, 1 out of 6, 0. We're going to get that decimal in a moment. But we could get no successes. We could roll this die 5 times. Oh, look, I got it on the first try. Stinks. Anyway, die is loaded. There's 2, there's 3, there's 4, there's 5. Yeah, that's 5 trials, no successes. What are the chances of that happening? Now, you could technically figure that thing out. Actually, I'm going to type it in my computer here. You could technically figure that thing out by taking 5 out of 6 times 5 out of 6. Actually, you know what? No, I'll just do it like this. It'd basically be 5 out of 6 raised to the 5th power. It'd be like 5 out of 6 times 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 5 out of 6. That would be getting nothing being that 4. And clearly it's like, oh, look at that. Cool. But with the binomial, it's a bit more complicated when you get to more successes. I'll talk about that when I get to 1 success. So I am going to use, and again, you need to get the practice with this. That's why you have the calculator open on your Chromebook right now, where I'm typing in the appropriate values. 5 trials, 1 out of 6 chance of getting a success, 0 successes. If you paste that, clearly you can see the probability of that event happening, which I'm going to write down as approximately 0.402 is what it rounds to. 0.402 is what it rounds to. There is about a 40% chance that if you rolled this die 5 times, that you would not get a 4. All right. What about 1 success? Binom PDF 5, 1 out of 6, 1. Now I'm going to walk up to the board for this one because I do want to show a visual for this. If you're getting 1 success, I'm going to equate this to being either a success or a failure. A success, I'm going to write as an S. I'm going to erase this, by the way, just so you don't have to write this particular red part in your notes. But an S would be a success, and an F would be a failure. If I'm going to get 1 success out of 5 rolls, I don't know when that success is going to take place. I don't know if I'm going to get that success on the 1st, the 2nd, the 3rd, the 4th, or the 5th roll. And instead of working my butt off to try and figure that out, this is where the function on the calculator comes to the rescue. Instead of figuring out all of those possibilities, I simply go to my calculator, chapow. I go to my binomial function. I change that 0 to a 1. Hit my enter. Oh my word, look at that. What do you notice? It's the same thing. Now that's a coincidence, but it's true. That is a coincidence, but it is true. It is absolutely true. And I'm going to write down the same number, the same approximate number, 0.402. That will not always happen. I want to emphasize that. That will not always happen. Let's do it again for 2 successes, though. And then I'm going to write down some more stuff in my notes. Let's change it to a 2, meaning I'm about to get 2 successes. Now, again, I'm going to come up to the board for this. Getting those 2 successes, it could be success, success, and the rest failures. It could be success, failure, success, success, failure, failure, success, failure, failure, success, failure, 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 success. Or it could be failure, success, success, failure, failure. Or it could be failure, failure. No. This can get very complicated, what I'm writing on the board right now. And I am not about to waste my time trying to figure out how many different ways those 2 successes could occur within 5 rolls of the die. I might be sitting here forever trying to figure out how many different ways that could occur. And instead of doing all of that work, I'm simply just going to hit enter right here. 5 rolls of the die, 1 out of 6 chance of getting a success, 2 successes, exactly 2 successes. Bam. Gives you a different number, clearly. But that's the number that I'm looking for. In my notes, this is what I'm going to write. Hold on. I'll show you my notes in a moment, actually. I want to write it down first so that I have the correct number. And then I will show you what I'm looking at. 0.161. There we go. Chapow. That's what I'm writing down right there. So, here's what I want you just to practice for a brief moment. I want you to get used to finding the function. I want you to get used to typing in the proper numbers. And I want you to get used to writing this thing out. Take a moment. It should only take you a very brief amount of time. But I want you to write out the last 3 that we need for 3 successes, 4 successes, and 5 successes. I want you to actually do that on the calculator, on your Chromebook, of course. Take the next minute, 2 minutes or so, write that out. If you've ever played Yahtzee, you would recognize the fact that there's a low chance that you would get a Yahtzee on one roll. Although it is possible. It's just unlikely. Oh, goodness. I once saw, okay, I have a buddy of mine who is a math teacher in New York City. He is I met him through Rubik's Cube competitions. He was a really nice guy. His name is Bobby. He puts out these like YouTube videos where he does like these like human achievement type situations where like he spent an entire day trying to learn how to ride a unicycle and like filmed his progress. He once tried or attempted to stand on his feet for 24 straight hours and showed like highlights of it during the video. It was really intense. He didn't make it. But if he does like stupid videos like that, he once learned how to play high-level chess, and then he went to Union Square in New York City, and he faced a chess street hustler and beat him. It was the coolest thing ever. Anyway, Bobby once spent 4 or 5 hours filming himself trying to get a Yahtzee on one roll. Trying to I was insane. Like, what are you doing? But his videos do pretty well on YouTube. It's like human achievements type stuff that he like edits down and stuff like that. She says all math teachers know each other. No, we don't. Anyway, I was going to give you the numbers for this real quick. I haven't actually done the calculations, but the numbers here should be approximately 0.032. Should be 0.0032. Now for this last one, it's in scientific notation, but I'm not going to write it in scientific notation. I am not going to write it in scientific notation at all. Boom. 0.00013. 0.00013. In your calculator, it does give it to you as scientific notation. I just translated it over. Now check this out. Here's the question I have for you. When I roll that die 5 times, 0, 1, 2, 3, 4, or 5 successes, is there any other possibility for a number of successes? Is it possible I could get 6 or 7 successes? Is it possible? Why? Huh? Chance? How many times am I rolling it? I'm only rolling it 5 times. I can't get 6 or 7 successes. I can't. It's impossible. I can't get anything less than 0 successes. I can't. These are the only possible outcomes that there are. This is the point that I'm getting to. This is the only possible outcomes that there are if you're rolling it 5 times. Obviously, if you roll it more, there are more possible outcomes. Look at these numbers off to the side. Take a wild guess. What do you think they add up to? Yeah, they do. If these are the only possible outcomes, what was that? Then those probabilities should be complete. They should be a complete whole. And when I asked what they should add up to, you indicated that they should add up to 1. Now, mind you, I rounded. Let me zoom in right here. I rounded. Let's just see what happens. 0.402 plus 0.402 plus 0.161 plus 0.032 plus 0.0032 plus 0.00013. Boom. That's pretty darn good. That's rounded. But yeah, they should add up to 100%. They should total 100%. That is the idea of a binomial distribution. What we've actually just done is we have mapped out a binomial distribution for this particular situation. Now, let me go back to my calculator real quick. Let me just show you this. We have been using the PDF. But I have also shown you the CDF. Please remind me, what does the CDF do? I have not talked about this today at all. But what does the CDF do? Ooh. I know, I haven't talked about this. I don't know. It's been a while, Mr. Markey. It's been like over 2 weeks. The C in CDF refers to the idea of cumulative. It is a cumulative probability distribution or density. It is a cumulative number, meaning there are things that are going to be added up. In your notes from before break, there should have been some information about PDF versus CDF. PDF is getting exactly that many successes. It's getting exactly X successes, whereas CDF was getting that many successes or less. So, let me show you this. Chappelle, 5 trials. 1 out of 6 chance. 1. Notice I'm using the CDF. CDF is cumulative. And if it is cumulative, I'm just going to write this over here. 0, 1, 2, 3, 4, 5, the possible successes. I am getting 1 success or less, according to what you just wrote down before. What are the chances that I got 0 successes? About 0.402, about 40.2%. What are the chances that I got exactly 1 success? Yeah, same number. It was the same number twice. Added up. What are those 2 numbers added up? So 80 or 0.804. So like 80.4%. CDF, cumulative, meaning 1 success or less in this example. Chapow, about 0.804. It adds them up for you. It adds them up for you. That's what the cumulative one does. When are we ever going to need that? Well, it depends on the question that's being posed. It depends on the question that's being posed. But that's what you're going to need for CDF. Check that out. What am I saying here? How many times am I rolling the die? 5 times. 1 out of 6 chance of getting success. How many successes am I looking for? Or 5 or what? Remember, it's a CDF. 5 or less, meaning either 5 or 4 or 3 or 2 or 1 or 0 successes. That's what the CDF actually means. It's a cumulative function. Remember what you told me? You told me, I said, hey, what do those all add up to? And you said 1. I did it by hand and it gave me like approximately 1. Amazing question. I have a worksheet. I'm not going to print. I didn't print it out. Right there. See if I can open this with this stupid thing here. Come on. Yes, connect to Google. Come on. How are you not already signed in? I opened you up earlier to save time, and now I have to go through this explanation. Oh, you've got to be kidding me. Come on. You had the right page. Okay. So I'm going to verbally talk about this, but this is going to answer that question. This is a scenario about the American Red Cross. Now, you don't have to write this down. I just want you to kind of see this and experience it with me. The U.S. population has type B blood. Anybody know if they have type B? You do? Good for you. All right. I'm O positive. That's O negative. Yeah. I know. It's so weird, right? O positive is probably the most common type of blood. Can donate to anybody. Yes, O negative is very rare. Yes. Like I said, I'm O positive, so meh. But 11% of the U.S. population is type B. Okay. A blood drive is being held at your school. Meh. They used to do that here. You know that? Yeah, like where people who were like seniors who were of age or teachers, they could go down to the gymnasium or the auxiliary gymnasium and donate blood. Pretty cool. They gave us crackers and juice afterwards. Anyway, yeah. Don't worry about number one. Don't worry about number one, but let's go down to number two. I'll scroll up. What is the probability that the 10th? No, not that one. I'll explain that one in a minute. There you go. Numbers 3 and 4. This will answer your question, hopefully, kind of. What is the probability that exactly 2 of the first 20 blood donors will have type B blood? And what is the probability that at least 2 of the first 10, they changed it, blood donors would have type B blood? 3 and 4. Oh, that has nothing to do with it. Nope. The number of blood donors has nothing to do with if it's CDF or PDF. It has to do with the wording of the question. In number 3, they say, okay, there are 20 blood donors, right? The number of trials is 20. There's 11% of the US population has type B. 11%, meaning the probability of success is 0.11. Meaning if I walk up to random people and be like, what type of blood do you have? Weird question. But 11% of them would say that they have type B. And they're saying, what is the probability that exactly 2? Exactly 2, meaning that's the number of successes. This is we need to know what's the chances that we would have. Sorry, she's making jokes about being positive and blood and stuff. It's funny. What is the probability that exactly 2 exactly is inferring to PDF getting exactly that many successes? In number 4, in the next problem, now there's only 10. That doesn't mean anything other than the number of trials. That changes the value of n. The probability of success is still 0.11, but now x is a bit of a question mark. And the reason why x is a bit of a question mark is because of the way that they're wording the question. They want to know, what are the chances that you get 2 successes or more? Because it says at least. At least, meaning 2 is the least, 2 or more is what that question is referring to. But what does CDF calculate? X success. What does CDF calculate? What does CDF calculate? Ooh. Or less. So, we are going to write something into our notes. And it is going to involve these 2 problems. So let's go back to our notes. So, Destiny, the long and short of your question is, which one do you use and when? It depends on the wording of the question. Yeah. But now this one has a bit of a twist to it. There's a twist. Trust me, there's a twist. So, the example that I'm referring to, number 3, talked about 20 donors. I'll show you what I'm writing in a moment. The probability of success is 0.11, and X is exactly 2 donors. Chapow. Nope, wrong one. Chapow. There we go. So example number 3, there were 20 donors. The probability of success was 11%. There were exactly 2 successes in this case. This is a Binom PDF, and I'll underline, emphasize PDF there. with this as its calculation. Binom PDF, because exactly 2 successes. Typically, when you have verbiage like that, they may not always use the word. They may use something similar to it. And in that case, yes, it's a PDF situation. And I'm just going to do the calculation right here, 20.11 to chapow. It gave you approximately 0.282. And if you did that on the calculator or on the calculator that's on your Chromebook, you would get the exact same number. But then with number 4, we run into a little bit of an issue. With number 4, we run into a little bit of an issue. And this is pretty much going to be the last question that we do today. This is what I planned on doing. In number 4, they changed the number of donors. The probability of success is still 0.11. But they want at least 2. They want at least 2 successes. So here's what I want you to do. I want you to write this out first. Write out those numbers first. Because like I said, this is going to inform what we do. Yes, because getting no successes is still a possibility. If you get 10 donors, is there still a chance that you would get no one with type blood? There's a chance. Yeah, there's a chance. I don't know what that chance is, but there is a chance of that happening. Being type B. Could be any one of those. But they want at least 2. They want at least 2. And since they want at least 2, they want the chance of that happening, what I just put in that box. They want the chance of getting 2 or more successes. Now, this is a little bit troublesome because the CDF calculation doesn't do that. The CDF calculation doesn't do 2 or more. It would do 2 or less. That's not going to help us here, so we're going to have to change our thinking. See, the thing is, they want 2 or more. Now, remind me. If, and I'm not actually going to do this, but if I did PDF for all of these, if I did PDF for all of these, all the way up, and I got 11 calculations, which I'm not going to do, what should those 11 calculations all add up to? Should add up to 100%. It should, and it does. But I'm not actually going to do that. Instead, I am going to utilize a definition that I talked about before break. I talked about a complement. A complement. A probability complement. The complement definition that I gave you was something along the lines of this. If the probability of A is 75%, what's the complement? 25. If the probability of A is 99%, what's the complement? 1. So we need all of this junk, but unfortunately, we're not going to get it. So we're going to perform a little strategy. And the strategy that we are going to perform is this. We're going to find the probability of this happening, and then we're going to find the complement, because the complement will give us the other half. It's not really half, but. So what I'm going to do on my paper, on my notes, I am going to calculate binom C df. Notice my underlining of the word of the letters C df. Parentheses 10, comma 0.11, comma 1. Because that will give me the probability of getting 1 or less. In this case, 1 or 0. I'll do that real quick right here for the sake of time. Chapow. It gave me approximately 0.697. Sky, I don't know when you actually typed that. Did you type that before? Hold on, 808. If you PDF for all of those and you got all 11 calculations, they should equal 100%. You're welcome for the reminder. Okay. But if I do that and get 0.697, 0.697 is not my answer. 0.697 represents the chances of getting 0 or 1, and all I have to do is calculate the complement. If I calculate the complement of that, meaning in this case 1 minus that answer, the answer that I am looking for is 0.303. That's what the complement allows you to do. Now, Destiny, in terms of the verbiage that you're looking for, this problem said at least. What I'm going to say is this. They may say at least, they may say at most, they may use all that. I don't know what they might say, or less or more. But basically, if they're asking you to calculate not exactly a certain amount, maybe, you know, they may do all sorts of different things, but this one said at least 2, meaning it's not just that one scenario. It's that one scenario plus more. CDF. Yeah. Now, I do want to show you one quick last thing. And I want to show you the comparison. Oh, sorry, I just read our comments again. So you get, most of you don't even see the comments. I'm having like my own little like fun time up here, you know. I'm going to scroll up to number 2. Look at number 2 up here. I'm going to read this one, and I want you to, I want to talk about this. This is going to be a verbal conversation right now. Same scenario, type B blood, same scenario. What is the probability that the 10th blood donor is the first one with type B? What is the probability that the 10th blood donor is the first one with type B? Yeah. One chance of that happening? Well, it would definitely be a PDF because by definition, it's looking for exactly that success, right? I agree. Here's the problem. It's not a binomial. Number 2, this problem right here, unfortunately, is not a binomial. See, they're looking for one particular situation. They're looking to get the first success on the 10th try. Meaning they're saying, well, screw all the different orders that it could occur. We're looking specifically for this. We're looking for 2, 3, 4, 5, 6, 7, 8, 9, success. That's what we're looking for. In this scenario, it's not a binomial. It's what they refer to as a geometric. Fun fact, you have that function in your calculator. You do. And I'm going to show it to you in a moment. A geometric calculation is basically looking, okay, well, when am I getting that first success? When am I getting that first success. That's what this problem is. First success. Check this out. On your calculators, chapow. Wait, yeah, there we go. If you go second vars, at the very bottom right here, you have two geometric calculations. And as you just said before, yes, it is a PDF. It is definitely a PDF because they are looking for exactly that trial. But look what they ask from you. Look what they ask from you in this geometric, Geomet PDF. They only ask for two things, P and X. The idea of a geometric is just try, the 11th try, the 15th try, the 20th try. Basically, there's no set number of trials. There's no set number of trials. There's no N. It's just success or failure until I get that first success. That's why for this problem, it's quite straightforward. Oh, no, it wasn't 1 out of 6. My bad. I'm still on the dice problem. It was 0.11. Type B below us next time. Basically, on Wednesday, I'm going to wrap up geometric. We're going to get to see some problems carrying the two against each other, the word problems that I just talked about, so you know which one to use, when, why, and how. And then we're going to be wrapping it up. Goodness gracious. Now, again, I have no idea when this bell is supposed to ring. It's supposed to ring 8:20, right? What all your phones say now? Okay. 8:24 is the beginning of second period. Yeah. So you guys have all 8:16. My watch says 8. I'm fairly confident the bell goes by this clock right here. Somewhat confident. I know. But the problem is this. I have students who are virtual, right? So, that's why I tried to delay usually at the beginning. Way off by a few minutes. Anyway, you guys are all missing out on the conversation in the chat. I'm just saying. You're all missing out on the experience. Do you just notice that? Yeah, it is backwards. What are you doing? Goodness. That's okay. Sorry, I'm just reading your comments again. Oh, gosh. No, but there's like 5 people in the chat. Now there's 4 people in the chat. I don't know, whatever. Anyway, I'm going to sign off in the live stream. I'm going to sign off in the live stream. Like I said, I'm going to be assigning things later this week, stuff with linear regression, and then we'll go from there. Oh, it's going to be so much fun. For me, mainly, for me. I enjoyed this. Anyway, I'm going to sign off, and I'll see those people in the live stream next time.